This will be for the con assignment, find trig values using angle addition identities. All right, so you're going to need to use the addition and subtraction formulas for trigonometric identities. Notice there is 2 identities for sine, a positive, negative, 2 for cosine, and 2 for the tangent, both positive and negative. And you may also need the half and double angle formulas. Notice the angle is halved for both the sine, cosine, and tangent. It's divided by 2. And then there's the double angle formulas. The angle S is multiplied by 2 for sine, cosine, and tangent. All right, so we have this mess right here, and they want us to find the exact value of the expression without a calculator. And it's multiple choice. So what I'm going to do is look at my formulas again and see which one matches this. Okay, in the numerator we have tan plus tan, and denominator 1 minus tan times tan. So looking at our formulas, it looks just like this one right here. Okay, so tan s plus tan of t divided by 1 minus tan s times tan of t equals tangent of s plus t. So this is exactly what we have. We just need to take the 2 angles and add them and take the tan function of those 2 angles added together. All right, so I can make this angle here equal s and this angle here equal t. And the whole thing is just going to equal the tan of s plus t. So that's going to equal the tan of pi over 12 plus 5 pi over 3. Now, some of these, it might make it easier to convert to degrees instead of radians, but in this case, it's not too bad. Okay, we just need a common denominator. So we know pi is the same as 1 pi over 12. And to get a 12 here, we'll multiply the top and bottom by 4. Okay, so 3 times 4 is 12. 5 times 4 is 20 times pi. And that's going to equal the tan function. 1 plus 20 is 21 times pi over 12. Hopefully that's on our unit circle. All right, one small thing I forgot is to reduce this fraction. So that's going to equal the tan. And these are both divisible by 3. All right, so 21 divided by 3 is 7. And we still have pi. 12 divided by 3 is 4. Like I said, if you want to convert these to degrees, it might be easier. Okay, so right here is the angle for 7 pi over 4. And remember, the first coordinate is the cosine and the second one is the sine. Now, we don't have tan on the unit circle, but we know the formula for the tan of theta equals sine of theta over cosine of theta. But on the unit circle, the sine is the y coordinate and the cosine is the x. So the y coordinate, we can see that is negative radical 2 over 2. So negative radical 2 over 2. And the x coordinate is just radical 2 over 2. All right, so the same number over itself, but there's a negative in there. So that's just going to equal negative 1. Answer C. Okay, here they want us to find the cosine of 7 pi over 12 exactly using an angle addition or subtraction formula. I would prefer to convert to degrees. All right, it just makes it easier because it's hard to find the 2 fractions that add or subtract to this value. So if you recall, pi radians is the same as 180 degrees. So just sub in 180 for pi. We have 7 times 180 divided by 12. And that equals 105 degrees. All right, so we basically have the cosine of 105 degrees. And we want to see if we can find an angle addition or subtraction formula. All right, we don't have 105 on our unit circle, but we want to find numbers that are on the unit circle that add or subtract to 105. Okay, and we are in luck as far as 105 is concerned. We can use 60 plus 45. Okay, the reason we're doing this is because we don't have an exact value for 105 on the unit circle, but we can use one of the identity formulas for addition to add these two and get the 105. Okay, so the cosine of 105 is going to be equivalent to the cosine of 60 plus 45. And now we just have to find the formula for adding two angles with cosine. All right, so we are looking at this formula right here, the addition identity for the cosine. Okay, we have cosine of s plus t, so cosine of 60 plus 45. That's going to equal cosine of s. So we're going to let s equal 60. We're going to let t equal 45. And we have s plus t in parentheses. All right, cosine of 60 times the cosine of 45 plus, I'm sorry, that's actually a minus, not plus, sine of s, so sine of 60, and sine of t, sine of 45. Okay, those are all in degrees. So we'll use this unit circle now. All right, I made some room. Cosine of 60. Remember, the cosine is the x-coordinate, so go to 60. Cosine of 60 is 1/2. Cosine of 45. 45 is here. Cosine is the x-coordinate, radical 2 over 2. And then minus sine of 60. So go to 60. The sine is the y-coordinate, radical 3 over 2. Times sine of 45. 45 is here. Y-coordinate, that's going to be radical 2 over 2. All right. 1 times radical 2 is radical 2, and 2 times 2 is 4. Minus radical 3 times radical 2 is radical 6. And 2 times 2 is 4. So the common denominator is 4. It's radical 2 minus radical 6 divided by 4. Final answer. All right, radical 2 minus radical 6 over 4. All right, here we're looking to find the sine of 19 pi over 12 using angle addition or subtraction. Once again, I'm not going to try to find two fractions that add or subtract to this. I am just going to convert it. We know pi in degrees is 180. So we have 19 times 180 divided by 12. And that equals 285 degrees. So I know that's not on the unit circle, but I'm going to find a pair of numbers that either add or subtract to 285 degrees on the unit circle. All right, so we have 285. I'm thinking 240 plus 45. So I'm going to use those two instead. Instead of 285, we're going to do 240 plus 45. Okay, like I said, the idea is to get values that are on the unit circle. All right, so we're using the sine function. So instead of the sine of 285, what we're going to do is the sine of 240 plus 45. So there's got to be an addition formula for that. All right, so sine of s plus t is sine s cos t plus cos s sine t. All right, so we will let the 240 equal s and the 45 equal t. So we have sine s cosine of t. So sine of 240 and cosine of 45, and that's going to be plus cosine of s, so cosine of 240, and sine of t, sine of 45. All right, these are all in degrees. So we just need to use the unit circle to find each one and then solve the equation. All right, cosine is x, sine is y. So sine of 240, we're looking at sine negative radical 3 over 2. Cosine of 45, and you can't see it here, but here's 45, the x-coordinate is radical 2 over 2. And that's going to be plus cosine of 240, the x-coordinate at 240 is negative 1/2. And sine of 45, you can't see it, but right here, 45, the y-coordinate is radical 2 over 2. All right, these are multiplied. So you got a negative here. Radical 3 times radical 2 is radical 6. And then 2 times 2 is 4. Got a negative here as well. 1 times radical 2 is radical 2. 2 times 2 is 4. So it's negative radical 6 minus radical 2. Negative radical 6 minus radical 2 over the common denominator of 4. All right, negative radical 6 minus radical 2 over the common denominator of 4. All right, so here we have a tan function. Find the exact value without a calculator. All right, so I'm guessing there's a formula where this is used as s and this is used as t. All right, so it's going to be tan s plus tan t divided by 1 minus tan s tan t. Let's take a look. All right, so that matches this formula right here. Tan s plus tan of t over 1 minus tan s tan t. So in that case, the equivalency is the tan of s plus t. So again, this was s, this was t. We're looking at the tan of s plus t. And this one, I don't think we have to convert to degrees. All right, so we have the tan of 5 pi over 4 plus 7 pi over 12. All right, we need a common denominator here of 12. 4 times 3 is 12. 5 times 3 is 15. So that's going to be 15 plus 7 pi. That's going to equal 22 pi over 12. And of course, we're taking the tan of that angle. And reducing, divided by 2 is 11. Divided by 2 is 6. We still have pi. We need to look for the tan on the unit circle, 11 over 6 pi. Recall the tan of an angle theta is equivalent to sine of theta divided by cosine of theta. But on the unit circle, the sine is the y-coordinate and the cosine is the x-coordinate. All right, so we said we were doing 11 pi over 6. So the y-coordinate is -1/2. The x-coordinate is radical 3 over 2. Keep this, change division to multiplication, and flip the denominator. So that's going to be 2 over radical 3. And now it's multiplied. The 2's cancel, and we have -1 over radical 3. They probably won't have this answer, so getting rid of the radical in the denominator, we multiply by the denominator over itself. And we have negative radical 3. And the denominator, radical 3 times radical 3 is just 3. Final answer. All right, negative radical 3 over 3. So they don't have the square roots in the denominator for these multiple choices.